Along the rugged coastline of Japan, an engineering marvel stands silent, colossal, and almost entirely unknown to the world. It is a barrier so vast, its shadow stretches for 400 kilometers, a distance equivalent to traveling from New York City to Boston and back again. This monumental undertaking, costing an unfathomable $12 billion, rises higher than a four-story building in places, a concrete titan against an omnipresent threat. Every single inch of its immense structure was painstakingly crafted, not by automated machines alone, but by human hands, driven by a memory etched in collective grief. This wall exists because of a day that tore through the fabric of a nation. It was March 11th, 2011. The ocean floor, a vast, unseen bedrock, convulsed, shifting a staggering 50 meters in a mere attering rupture, displaced 500 cubic kilometers of water, unleashing a wave that crossed the entire breadth of Japan in just 30 minutes. It arrived not as a gentle swell, but as a moving wall of black, churning water, reaching heights of 40 meters. Nothing in its path could survive. 90% of Japan's existing seawalls, once deemed impregnable, crumbled in that single hour. Every engineer across the archipelago took notice. Even the world's largest breakwater, a $1.6 billion testament to human ingenuity, was obliterated in mere seconds. It did not shatter from the front, as one might expect. Instead, the monstrous wave simply topped it, spilling over and attacking the structure from behind. The very foundations, designed to withstand unimaginable pressures, vanished beneath the relentless scour of the receding water. This was the fundamental engineering problem, not just impact, but inundation and erosion. In the aftermath, a blueprint for survival emerged from an unexpected place. In one small village, a single mayor, defying conventional wisdom, had insisted on a higher wall. His foresight saved 3,000 lives. This singular success provided Japan with its harrowing lesson: build it taller. The challenge was monumental. How does one design a barrier capable of holding back an entire ocean? The brutal truth emerged. This new generation of walls was never conceived to fully halt a wave on the scale of 2011. Its purpose was more nuanced, more strategic. And here lies the true marvel of its construction. Most of this colossal defense system remains hidden. Only 14 meters of its true height are visible above ground. The vast majority of its bulk, its true strength, is buried deep beneath the earth. Before a single stone was laid, engineers meticulously modeled this wall 200 times in advanced computer simulations. The result is a dynamic, adaptive structure. Its height constantly shifts, changing with every kilometer. It stands taller on exposed headlands, where the ocean's fury is most direct, and subtly lower in more sheltered bays, where the topography offers natural protection. Every curve, every rise, every fall is precisely calibrated from decades of wave data. The project demanded an unprecedented level of coordination, involving 440 separate construction teams. A single bankruptcy, a single failure of one team mid-build would leave a critical gap in the wall, a vulnerability that could prove catastrophic. There was zero tolerance for error. Before any heavy machinery could begin excavation, specialized survey ships meticulously drilled the seabed, mapping the unseen world beneath. Every section of the coast presented a unique challenge: soft clay, dense sand, or impenetrable hard rock. Each required a completely different foundation, a bespoke engineering solution tailored to its specific geological demands. The first arduous task involved the demolition of the very walls that had failed, a painstaking study of every fracture, every point of collapse. Only then could the new, larger, more resilient structures begin to rise. 400 kilometers of coastline, measured meter by painstaking meter before a single machine even touched the earth. This preparatory phase alone consumed months, a testament to the scale of the undertaking. Even the clearing of entire coastal pine forests, a necessary sacrifice, always. This wall, a testament to human resilience and engineering brilliance, stands as a silent sentinel. It is a monument to what was lost, a shield against what might come again, and a constant, stark reminder of the ocean's untamed power. The ocean, a force both giver and taker, granted them a fleeting window, precisely 4 hours each day upon the exposed seabed. Every single minute became a precious commodity, a relentless countdown against the returning tide, a silent clock dictating the pace of an impossible endeavor. Beneath the churning surface, the ground itself conspired against them. Vast zones of treacherous, yielding clay could not even bear the weight of a standard bulldozer. It was a landscape of perilous softness, a subterranean quicksand threatening to swallow man and machine whole. Yet, ingenuity provided a lifeline. Massive steel road plates, meticulously positioned, spread the colossal load, allowing heavy machinery to seemingly float above the treacherous mud. A deceptively simple solution, born of desperate necessity, transformed a crisis of stability into a foundation of defiance. 25 meters below the furious waves, in the very heart of the active surf zone, the true battle began. Here, where the ocean's raw power manifests with unyielding force, the foundation of a monumental defense was taking shape. Invisible to the human eye, divers in the spectral realm beneath the waves guided 5-ton boulders into their precise positions. These colossal anchors were carefully placed in the same unforgiving ocean that had, only recently, ravaged the coastline above, leaving a trail of destruction in its wake. Engineers, tethered to the surface, could not witness this underwater ballet. Their only connection to the unseen progress was the cold, hard data streaming from sonar arrays, demanding absolute trust in every digital reading. Between the massive boulders and the compacted fill, an unseen, critical filter layer was meticulously laid. To miss this fragile barrier, to allow even the slightest imperfection, would condemn the entire structure. Without it, the wall would slowly, insidiously bleed away, its integrity compromised by the relentless migration of fine soil particles, a slow surrender to the ocean's patient erosion. After weeks of unseen toil beneath the waves, the rubble mound, a testament to human will, finally broke the sea surface. A defiant emergence, marking a new chapter in this epic construction. But the challenge was far from over. Now, a specialized geotextile membrane, a silent guardian, was carefully draped over the nascent structure. This fabric, seemingly delicate, possessed an enduring strength. Its microscopic weave engineered to tirelessly prevent fine soil particles from migrating into the rubble, working silently, eternally, to preserve the wall's internal structure. An uncompacted mound, left to its own devices, would settle unevenly, an insidious creep leading to catastrophic structural compromise. A foundation that settles without uniformity inevitably tilts the entire defensive wall, rendering it vulnerable. Every single pass of the colossal rollers became a critical act of prevention, a meticulous choreography against the forces of failure. The slope angle, a precise 1 to 1.5, was an exact science. Any steeper, and the very boulders meant to protect would slide away. Any flatter, and the incoming waves would merely wash over it, failing to dissipate their immense energy, striking the wall with their full, destructive force. From nothing, a formidable platform was rising within the ocean's embrace, a defiant edifice against the boundless expanse. With its emergence, the true construction of the wall could begin above the waterline. Sheet piles, massive steel sentinels, were driven 10 meters deep into the unforgiving ocean floor. not merely to form the wall, but specifically to protect its crucial toe. Their Z-profile interlocked with an intricate precision, a critical detail that ensured the seamless transfer of immense shear forces between every single pile in the wall, forging a monolithic strength. This steel bulwark, counterintuitively, was designed to fight the retreating wave, not the arriving one. The true destroyer of foundations, a phenomenon known as squash scour, is born from the ocean's insidious retreat. The backwash, a predatory vacuum, relentlessly pulls the foundation sand out from beneath the structure. And then there are the unseen adversaries within the earth itself. A single buried boulder encountered during the pile driving could deflect a 12-meter pile sideways, destroying the entire alignment, compromising the integrity of the entire section. The solution was brutal, yet surgical. Pre-drill the boulder, crush it into submission, and then drive the pile straight through the cleared hole, a clean, unyielding path to absolute dominion. The scale of the effort was staggering. 30 dump trucks ran 16-hour shifts, non-stop, a relentless ballet of earth moving. One single breakdown, a momentary pause in this synchronized effort, could stall the entire compaction cycle, creating a cascading failure in the critical process. The fill itself was laid in precise 300-millimeter lifts, no more, no less. Too thick, and the compactor's immense force would never reach the bottom layer, leaving pockets of weakness. Inside the very body of the seawall, unseen geotextile reinforcement layers were meticulizing decree governed every stage. 98% proctor density, or the inspector would immediately shut the entire job down. Every single layer, every single lift was rigorously tested. One could press a foot onto 98% proctor fill and nothing would move, an unyielding, tangible proof of its integrity. But at 85%, the foot would sink, a stark, unforgiving threshold between resilience and catastrophic failure. 300 millimeters of progress, day after day, a measured ascent against the relentless march of time. 18 months remained until the first predicted tsunami season. 18 months until this colossal wall would face its ultimate test. The countdown had begun, a race against the ocean's inevitable fury. And at its very heart, providing an impermeable core, lay the clay, the wall's internal waterproofing, its silent guardian against the insidious creep of the sea. The earth, a silent canvas, often conceals its true fragility beneath layers of well-compacted clay. For centuries, this dense, impermeable barrier was trusted to hold back the relentless seep of water, a natural bulwark against the forces of erosion. Yet even the most ancient defenses can be overwhelmed. One night, the sky wept with an intensity few had ever witnessed. Rain, a ceaseless deluge, hammered the land. The ground, saturated beyond its capacity, groaned under the weight. Then, without warning, the very slope surrendered. 600 millimeters of earth, a vast, heavy mass, tore free from its moorings, collapsing into a destructive cascade. It was a stark, brutal reminder that even the most resilient natural barriers possess a breaking point. The aftermath demanded more than mere repair. It called for a complete reimagining. The entire section, a sprawling wound in the landscape, had to be meticulously rebuilt from its very foundations. No patch, no simple reinforcement would suffice. This was a total reconstruction, a testament to the unforgiving lessons etched into the earth that night. Now, a hidden artery of defense courses beneath the surface, an intricate network of drainage pipes, meticulously woven into the embankment's core. These unseen channels are designed to intercept and redirect water before it can ever accumulate, before it can begin its insidious work of undermining. Above ground, a protective skin is deployed. Before every rain, without exception, a robust geotextile fabric is carefully unfurled across the slope. This is not a temporary measure. It is a permanent, unwavering commitment to vigilance, a constant shield against the sky's unpredictable fury. Towering above the newly secured ground, a monumental structure begins to rise, reaching a formidable height of 10 meters. Across the horizon, thousands of concrete panels, each a precisely engineered component, are being prepared for their final destination. This phase, the very assembly of the colossal barrier, represents the absolute zenith of the project's complexity and its ultimate vulnerability. Beneath its stoic facade, this wall possesses an unseen nervous system. Embedded deep within its concrete heart are an array of sophisticated sensors. These instruments allow engineers to perceive the structure's subtle shifts, to watch it breathe and settle, to monitor its every minute adjustment against the immense pressures it will inevitably face. This observation is not fleeting. It is a perpetual vigil, an unending commitment to understanding the wall's silent dialogue with the earth and the sea. Before any of the massive panels can be placed, the foundational face must achieve an absolute, uncompromising flatness. Even the slightest deviation, a single bump no larger than a coin, can become a catastrophic point of weakness. Such an imperfection would create a concentrated stress point, a hidden flaw destined to fracture under the immense, unyielding force of a raging ocean. The wall itself is a triumph of integrated design, a singular entity fulfilling three distinct yet interwoven functions. It must grip the seabed with an unyielding hold, anchoring itself against the raw power of the currents. It must form an impenetrable seal against the water's relentless penetration, preventing any insidious ingress. And, critically, it must bear the enormous structural load, standing firm against the ocean's full might. Three materials, three vital jobs, coalescing into one unified, unyielding wall. The margin for error in this monumental construction is razor thin. Each of these colossal panels weighs a staggering 7 tons. If even one panel, during its delicate curing process within the mold, develops a crack, the ripple effect is immediate and devastating. An entire week's meticulously planned production schedule is instantly shattered, a costly setback in both time and resources. Every single hairpin bar, a deceptively simple piece of reinforced steel, forms a critical, unbreakable link connecting each massive panel directly to the overarching crown wall. The absence of even one such bar would compromise the entire structural integrity, unraveling the interconnected strength of the whole. To ensure this flawless integration, self-compacting concrete, a marvel of modern material science, is poured. It flows with an almost liquid grace, enveloping every single bar, eliminating any voids, and forming a perfectly smooth, unblemished face. There can be no honeycombing, no hidden pockets of weakness. This meticulously crafted surface is not merely designed to withstand the ordinary ebb and flow of the tides. It is engineered to resist the unimaginable, to stand defiant against the cataclysmic force of a tsunami. The precise consistency of the concrete mix, known as its slump, is paramount. A wrong slump during the pour can lead directly to honeycombing on the panel's face, creating a porous, weakened surface. A single flawed batch of concrete, a momentary lapse in precision, can condemn an entire day's production run, forcing the costly destruction of countless panels. Quality control is an art form, a symphony of precision and discernment. Listen to the tap. A solid, resonant ring signals concrete of impeccable quality, a sound of structural integrity. But a hollow, dull thud? That sound is a death knell. It means the panel is compromised, destined for the crusher, regardless of its cost. There exists zero tolerance for defects on walls designed to defy a tsunami. A single panel, valued at $800, will still be mercilessly crushed if it fails this ultimate auditory test. The cost of human life and safety far outweighs any material expense. The logistical challenge of transporting these 7-ton monoliths across Japan's often narrow coastal roads is immense. Each journey is a meticulously choreographed ballet of precision and caution. Flagmen are stationed at every single junction, guiding the colossal loads through winding pathways. 400 kilometers of perilous terrain must be navigated, each mile a test of patience and planning. The foundation bed upon which these titans rest must be leveled to an astonishing tolerance, just 5 millimeters. A barely perceptible hump, a mere 5 millimeter elevation, could exert enough localized stress to crack the corner of a 7-ton concrete panel, rendering it useless. This face, once installed, must be capable of absorbing the full impact of a tsunami traveling at 30 kilometers per hour. It must stand unyielding, not for years, but for a full century, safeguarding generations. The concept of a 400 millimeter R, when one envisions a tsunami, a liquid hammer, attempting to rip each individual panel from the wall. This generous overlap is a critical safeguard, ensuring that the wall remains a cohesive, unbroken barrier. An ingenious defense lies hidden within the joints, a rubber water stop. When exposed to water, this material possesses a remarkable property. It swells. The greater the force of the incoming wave, the more water permeates the joint, and the tighter every single seal becomes. The wall actively reinforces itself against the very force it is designed to repel. The natural world, however, rarely conforms to straight lines. Constructing straight panels along a curved coastline presents a formidable engineering dilemma. Without precise customization, gaps of up to 20 millimeters would inevitably open between the panels. Through these minute fissures, water would be forced under extreme pressure, insidiously undermining the entire structure from below. The solution is a testament to bespoke engineering. 37 unique panel shapes, each meticulously crafted. These custom forms are brought to life through CNC machined molds, ensuring absolute precision in every curve and angle. The result is flawless. Every single gap closes to zero, creating a continuous, impenetrable barrier. One curved bay, once a point of vulnerability, is now perfectly sealed. The pace of construction is relentless. 400 meters of this sophisticated barrier can be sealed in a single week. Yet, the looming deadline of 2022 continues its inexorable countdown. 440 teams, a veritable army of engineers and laborers, are racing simultaneously against both the clock and the elements. The crown wall, the uppermost section of this monumental defense, is not merely a cap. It is a strategically designed feature, angled to actively deflect overtopping water, throwing it back towards the seaward side. This single, critical detail, a subtle curve in the concrete, stands as a silent protector, safeguarding thousands of lives and countless homes. The crown wall, through the very same hairpin bars that secure the panels, grabs every section below it, binding them into one integrated, monolithic structure, not a collection of individual, stacked pieces. Even during the pour, precision is paramount. The pump boom, extending its reach to a maximum of 15 meters, is a vital lifeline. Should it fail mid-pour, a catastrophic cold joint would form, creating a permanent weak point within the concrete. The wall, designed for absolute integrity, would be fundamentally compromised. Every degree of deviation from the vertical, every fraction of an inch, represents a critical threshold. A wall designed to stand for a century against the ocean's fury must be absolutely plumb, an unyielding testament to human ingenuity against the raw, untamed power of the sea. The ocean's raw power, a force that grinds mountains to dust and reshapes continents, meets its match in a single, elegant design. A subtle curve, barely perceptible to the casual eye, turns the tide. This specific angle, meticulously calculated and forged in concrete, redirects the colossal weight of overtopping water, deflecting it outward, away from the vulnerable land, instead of allowing it to crash inward with devastating force. It is a stroke of simple genius, a silent testament to engineering's quiet triumph over chaos. Along 400 kilometers of formidable wall, a solitary embellishment breaks the stark, utilitarian gray, a delicate wave pattern stamped into the coping. This subtle motif, an almost ironic nod to the very power it defies, is the sole concession to aesthetics. For 5 long years after its completion, every millimeter of the crown wall's height is meticulously measured, its structural integrity scrutinized. The monitoring, a relentless vigil against the Earth's ceaseless shifts and the ocean's unending assault, never truly ceases. What appears from a distance as a monolithic, uniform barrier is, in truth, a marvel of layered complexity. 6 distinct materials, each chosen for its unique properties, converge to perform 6 critical engineering functions. The exterior presents a facade of unassuming gray, yet beneath this stoic surface lies a sophisticated symphony of strength and resilience. The unseen rear face of the wall is just as vital as its exposed front. History whispers a stark warning. The catastrophic failure of older defenses often began not with the initial impact, but with the relentless pressure exerted by water trapped behind the structure. If the ocean ever breaches the wall's crest, that water must find a safe escape. The landward drain, an intricate network of channels and conduits, stands ready as that indispensable escape route, preventing the buildup of destructive hydrostatic pressure. Then there are the tetrapods, 32-ton concrete behemoths, each sculpted into a distinctive 4-legged form. These are not merely placed, they are dropped, often from great heights, into the churning waters. Each block must interlock perfectly with its neighbors, a complex dance of geometry and mass, for if even one shifts, the entire armor layer risks catastrophic failure in the face of the first major storm. A single leg invariably points skyward, ready to embrace and secure the next tetrapod above. This ingenious interlocking mechanism is not merely for stability, it is the very heart of their defense. It transforms the brutal energy of an incoming wave into a distributed, dissipated force upon impact. The apparent randomness of their placement, the seeming chaos of their arrangement, is in fact the genesis of order. The gaps between these colossal forms are not weaknesses. They are the fundamental mechanism of their protection. Water, finding these intricate pathways, flows through, its destructive energy gradually dissipated, absorbed, and broken down. Imagine a single liter of water, its force completely neutralized. Now amplify that by the terrifying scale of a 50 million ton tsunami, and the sheer brilliance of this design becomes chillingly clear. Such calculations are not left to chance. A precise formula, known as the Vandermeer equation, governs this monumental task. Input the raw, untamed energy of an anticipated wave, and the equation yields the minimum required weight for the armor layer. 40 of these colossal tetrapods are produced every single day, a relentless industrial rhythm necessary to protect 400 kilometers of vulnerable coastline. The fabrication yard, a sprawling expanse of concrete and steel, operates without pause through the harsh light of day and the unforgiving darkness of night. Below the waterline, where no human eye can penetrate, these tetrapods accumulate in unseen, silent mountains. Sonar probes the abyssal depths, revealing what no diver could ever reach, mapping the hidden architecture. 3 distinct lines of defense precede the main wall itself: a massive rubble mound, a deeply embedded sheet pile toe, and finally, the dense, interlocking tetrapod armor. This multi-layered approach ensures that the tsunami, before it even reaches the primary barrier, is forced to exhaust the vast majority of its devastating power. Even with such monumental safeguards, the vigilance remains absolute. Every section of the wall, every new design iteration, is rigorously tested in a specialized wave tank, simulating the most extreme conditions imaginable. And sometimes, the results are unexpected, revealing new challenges. Along the wall's immense length lie 443 critical gaps, each one a potential death trap should a single floodgate fail to perform its duty. The concrete encasing these floodgates is twice the thickness of the standard wall, a silent acknowledgement of the immense, concentrated forces that will bear down precisely at these points. From the moment an alarm sounds, a mere 70 seconds are allotted for the massive gates to seal completely, the only fragile window before the wave strikes the coast. A sophisticated seismic sensor, devoid of human error or hesitation, triggers the automatic closure. No human intervention is needed, or indeed possible, in such a critical, fleeting moment. The instant the earth trembles, the gates begin their inexorable descent. These are not simple barriers. Each gate moves with a mere 15mm clearance, a 50-ton slab of steel descending with terrifying precision. Even during installation, battling 40km/h coastal winds, the tolerances are unforgiving. These gates are engineered to withstand 1.5 times their design pressure, a margin of safety against the unimaginable. Yet, if even one of the 14 critical seals leaks, the entire gate is compromised, its protective function utterly negated. A leak of 40 liters per minute through a 2mm gap, seemingly insignificant, becomes a raging torrent under the crushing pressure of a real tsunami, widening that gap to 20mm. Such a flaw demands immediate, uncompromising action. 2mm are meticulously ground off the offending surface. The gate is retested. 0 leaks. 3 agonizing hours of painstaking machining, a testament to human precision and dedication, can be the difference between a town's survival and its utter annihilation. Imagine a driver, caught unaware, traversing one of these critical gaps when the seismic alarm screams its warning. The gate, an immense, unyielding force, begins its descent. 70 seconds. That is all the time the world allows. It is a stark reminder that even the most monumental achievements of engineering, designed to protect us from nature's fury, operate on the razor's edge of precision, demanding an eternal, unforgiving vigilance against the very power they seek to tame. The relentless clock counts down. A tsunami wave, a liquid mountain, charges towards the coast. At the river's mouth, a Tweevery system falters. Gravity itself becomes the final fail-safe, pulling the colossal barrier into place. Across a vast coastline, 443 gates stand sentinel. From a single command room, a silent vigilance monitors them all. 4 minutes, 20 seconds. This is the window. This is the precision honed by annual drills, a solemn ritual observed every March 11th. A 400-kilometer wall, not merely a structure, but a sentient network. Every gate, every sensor, every alarm feeding into a singular intelligence. The wall thinks for itself. Where the land plunges directly into the sea, where no beach exists, the wall becomes one with the earth. It is not merely built on the rock, it is woven into it. Rock bolts, driven 2 meters deep into ancient basalt, anchor the defense. Coastal winds howl at 50 kilometers per hour during the arduous drilling, yet the work continues, fusing the wall directly to the mountain's core. Concrete, not poured, but sprayed at 100 kilometers per hour, achieves a molecular bond superior to any traditional method. The cliff itself transforms, becoming an impenetrable shield. When the tsunami finally strikes, it meets a unified face. Concrete, seamlessly bonded to shotcrete, inextricably linked to basalt. 3 distinct materials forged into a single, unyielding entity. Nothing moves. Yet, even before the main coastal wall, another defense lies hidden beneath the waves. 200 meters offshore, a submerged breakwater stands ready to trip the colossal waves, dissipating their fury before they ever reach the shore. Picture this: a 60,000-ton box, a leviathan of steel and concrete, floating precariously in 3-meter swells, destined for a depth of 63 meters. The sea itself fights back. 30-knot winds whip the surface, and the immense structure drifts 8 meters off its intended mark. But failure is not an option. The rebuilt Kamaishi breakwater, a monument to resilience, now surpasses the very world record it replaced. The mantra is absolute: always build back stronger. Every single panel, every component, faces an unforgiving crucible. Should even one fail a strength test, an entire week's production, thousands of tons of material, is condemned to the crusher. The margin for error is microscopic. A mere 2 millimeters of carbonation is the maximum allowed, ensuring the vital steel reinforcement within remains shielded from corrosive sea air for at least 100 years. Independent inspectors wield absolute authority, empowered to condemn any section, to order its demolition, regardless of cost or delay. 440 contractors operate under this relentless, unyielding pressure. Gate frames are pushed to twice their design load, engineers scrutinizing every flicker on their strain gauges. The steel groans, it shudders, but it holds. It holds beyond expectation. Across 400 kilometers of shifting coastal sand, over 2 years, the differential settlement measured a mere 14 millimeters, an extraordinary feat of foundational stability. Then, the Earth itself unleashed its fury. A 7.4 magnitude earthquake ripped through the region. Instantly, the sensors fired. All 443 gates, in a symphony of steel and hydraulics, began their simultaneous descent. When the tremors subsided, the inspection revealed an almost unbelievable truth: 0 cracks. Not a single shifted tetrapod. This was not a drill. This was a real 7.4 earthquake. And the result was nothing short of extraordinary engineering performance. The final pump hums, pushing concrete into the last section. 400 kilometers. The immense barrier is almost sealed, almost complete. It feels almost alive. Right now, a helicopter sweeps the entire 400-kilometer expanse, its cameras capturing a panoramic truth that promises to redefine engineering for generations to come. The elegant staircases ascending its flanks are not mere scenic overlooks. They are meticulously designed emergency evacuation routes, born from the precise science of crowd flow. Today, people cycle along its crest, walk their dogs, begin their mornings with a run. The wall, once a stark line of defense, has transformed. It has become a daily promenade, a seamless, integral part of life itself, a testament to human ingenuity, a silent guardian against the ocean's wrath, standing not just as a barrier, but as a living monument to resilience. Built to endure, built to protect, built to live alongside.